We present reach prediction using finger motion dynamics. When we reach to grasp an object, the hand folds naturally according to this object. The aperture of the grip is correlated with the size of the object. The shape of the grasping fingertips is correlated with the shape of the object. But most importantly, the hand starts pre-shaping very early and the grip is formed long before we reach the object. Therefore, we have investigated how much information we can predict from local finger motions alone. To answer these questions, we need a data set on how users' fingers move while they reach to grasp an object. For this, we selected a set of synthetic and real objects, instrumented the user's hand with 12 electromagnetic markers, and let them grasp an object and move it to a target position. We collected data from 16 participants. This data was then calibrated, and we calculated the local offsets between the adjacent finger sensors. In this way, we removed the global position from the data, but kept the hand orientation and the local finger motions. We used these features to construct a multivariate time series that describes the overall grasp gesture. The time series were then split into small chunks of about 50 milliseconds, and then used to train a very small LSTM neural network. We deliberately used a small and shallow network to avoid the case where the network can learn the entire dataset. In addition, such a small network can easily be implemented on an MCU. Therefore, it can be integrated directly onto hardware of future input devices. Simply put, this approach worked. We could estimate precisely how far a target is and the target size. The time until the hand reaches the object can also be predicted, albeit a bit unprecise. Unfortunately, the algorithm could not discriminate robustly between the target objects, but it is basically because it commonly confused object grasp in a similar way. Overall, we can say that using finger motion dynamics, we can extract useful information before the user interacts with the object. Object shape is difficult to discriminate, especially for objects with similar affordances. In most cases, we have reliable information about 200 to 300 milliseconds before the user reaches the object. In the future, we want to extend the dataset to cover all common grasp types and to further look into what makes object types so difficult to discriminate. Until then.